Okay, so today we're going to do solving radical equations. And just so you know the difference, and you guys probably already know this, but this would be a radical expression because there's no equal sign. And then an equation would look like radical x equals 4. This is an equation. Okay. And you guys probably have experience solving radical equations from last year, solving for x. So just to recall from last year, you're going to notice on your homework that I will be using radicals and rational exponents. So if I give you the square root of x and I say convert that into using a rational exponent, that would look like x to the power of 1/2. Okay, and so sometimes I forget the rule on this, and so I always use this as a point of reference. So I think to myself, there's an imaginary 2 right here, and then we're raising x to the power of 1. And so the 1 is the numerator and the 2 is the denominator. So if I give you x to the power of 2/3 and I want you to convert that using a radical, it would look like the cubed root of x squared. Does that make sense? Okay, perfect. Now, from last year, if I wanted you to undo, say you have x to the 3/4, how would you get rid of that exponent? Say that equals 4. Well, to get rid of that rational exponent, you have to raise both sides to the power of 4/3. So you'll just raise it to its reciprocal, basically. And then you would take this side to the power of 4/3. Is that okay? Perfect. So for our first example, and this is a pretty easy example, I have 3 equals radical 5x minus 8. And you want to solve for x. So what value of x makes this statement equal 3? So what do you think we should do? Square each side. So we've got to eliminate the radical. That's what we have to do. So I'm going to get rid of this radical by squaring both sides. So 3 squared is 9. And when you square that radical, it goes away, leaving us with 5x minus 8. Then add 8, which is 17 equals 5x. And then divide by 5, leaving us with x equals 17 over 5. And that's our answer. The first 4 problems on your homework will look a lot like that. Okay? Yeah, not bad, huh? The next, so problems 5 through 7 will be just a little bit more difficult. And then number 8 is the challenge problem on your homework. I'm not going to show you how to do it. I'm going to let you think about it. I'll just give you a hint. Okay, so the second example, example 2, and like I said before, this is just like problems 5 through 7 on your homework. You're going to see the problem, quantity 5x squared minus 7x minus 8 to the 3/4 equals 8. So the first thing we have to do is get rid of that rational exponent. And how do you think we'll do that? Yeah. Raise it to the power of 4/3 on both sides. We have to treat everything equal, so what we do to one side, we do to the other. The nice thing is these go away on that side, leaving us with 5x squared minus 7x minus 8 equals 8 to the 4/3. If you're going to use your calculator to help you calculate 8 to the 4/3, it's really important that you input it correctly, because you could have a serious error if you don't. So what you have to do is you have to put that exponent in parentheses. So if you're going to take 8 and raise it to the power, oh, I have math print. Let me get rid of this math print. So 8 to the power, and then in parentheses, we have to go 4 divided by 3. And that will give us the correct answer, which is 16. But look what happens if you don't put the 4/3 in parentheses. What that's doing is it's taking 8, raising it to the power of 4, and then dividing that whole quantity by 3. And so you'll get 1,356 or 65, which is wrong. Okay? Does that make sense? So make sure you put the 4/3 in parentheses. Otherwise, you will get a very wrong answer. Okay? You could also do it individually if you want. So 8 to the 4/3 is 16. So we have 5x squared minus 7x minus 8 equals 16. So what do you think we're going to do from here? Yeah, minus 16 from both sides. So we have 5x squared minus 7x minus 24 equals 0. And this is something we're familiar with. We could use the quadratic formula to solve for x. So we'll get, using the program in our calculator, a equals 5, b is negative 7, and c is negative 24. And so you get x equals negative 1.6 and x equals 3. Okay. Just like solving rational equations, we actually have to test these values, because there will be an instance where only one of them works. Because what might happen is if you plug in negative 1.6 into your function, you might be taking the square root or the fourth root of a negative number, which you can't do. So you just have to test that. So if you would like to use your calculator, you could use your calculator and type in the original function, which is, in parentheses, 5x squared minus 7x minus 8 to the power of, and I'm going to put my 3/4 in parentheses, otherwise I'm not going to get the correct answer. Then go to my table and I typed in negative 1.6 and the output is 8, and that's what I wanted. I wanted this function to equal 8, so negative 1.6 works. And then when you type in 3, you also get negative 8, so that works as well. Any questions? Pretty simple.